Good morning, boys. I hope you're well. Welcome to today's lesson. Today we're looking at solving problems with trigonometry. So far what we've looked at, we've kind of introduced trigonometry. We've looked at finding the sides of a triangle using trigonometry, both numerator and denominator being the unknown. And we've most recently been looking at finding the angle in a right angled triangle using trigonometry. So today what we're going to do, we're going to use that information, we're going to put it all into place for those sort of part B style questions, those problem solving worded questions. Now, for some of the examples, you'll be given diagrams, so it makes it a lot easier. It's not like a normal question. The harder questions, of course, are where there is no diagram provided and we need to construct our own diagram. Now, before we do that, of course, I might just revisit our steps. I'll keep on harping on about our four main steps for solving problems, right? The first step I keep on saying is that we want to label the sides, right? Label the sides, always in regards to the angle. Now I'm talking, of course, of our opposite, of our adjacent, and our hypotenuse. And usually it's just the two sides that we're labeling. Once we've labeled our sides, of course, we want to choose the rule or identify the rule. Of course, when I say rule, it's more ratio, but that's my sine, my cos, and my tan. Now, once I've chosen my correct rule, we want to then apply the rule to the question. So we sub in the values, the angle, and the two sides. And the last part, of course, is to solve the equation. Now, today's questions, it's going to be exactly the same as this realistically, except there's probably going to be two extra steps. There'll be a first one, and that will be to have a diagram. Now, I say have a diagram because you might be given a diagram or you might be expected to construct your own diagram. And the last one will be to answer the question. Now, I know that sounds pretty straightforward, right? And often when you solve the equation, you might say, but I've answered the question, I've solved my equation. We want to put it into, I guess, perspective of the question itself. So there's going to be little stories around it, like you might have a boy who's 10 meters away from a tall tree and the angle there is 60 degrees, find the height of the tree. So it's just making sure that you bring meaning to your number. So you're not just saying x equals 2, it might be x equals 2 meters, it might be the height of the tree is 2 meters, etc. Now, in order to answer these questions, there's two pieces of new information that you guys need to know about. Now, in order to look at this, I'm going to kind of draw a little triangle here, my right angle triangle. Now, in these questions, as I said before, they're going to be applied, right? So we're going to have a nice little story. Often we have things like trees. Okay, I'm going to do a nice big tree here. Okay, and then you might have a little boy on the left-hand side here, and he's looking up to the tree. And so there's going to be two things that they might talk about. They might talk about the angle of elevation from the boy to the top of the tree. So you think where the boy is, and he looks sort of across and then up. You can see that where that triangle starts to create, that angle inside is where the angle of elevation would be. In this case, of course, it'd be sitting inside there. That would be my, and we're going to write that down, the angle of elevation. And so more so, it's just taking the three pieces of information that they're giving you. It might be being given two sides and having to find the angle. It might be given the angle on one side and us find the third side, or the second side, I should say. So it's always those three pieces of information that you have to put on that diagram. So angle of elevation will often be one they talk about. The next one is what we call the angle of depression. Now, a lot of students, unfortunately, when we hear angle of depression, they say, it's going to be in that top angle there because depression means to go down. And in one respect, it's true, right? Depression means to go down. However, think about if you're sitting at the top of that tree and you're looking at the boy. You're kind of looking across and then you're looking down to where that boy is. And if you look across first, if you look across first, and then down to where that boy is, what you see is that's actually where my angle of depression kind of occurs. My angle of depression sits in like that. So we're looking across and then down to where that boy is. Now that's important because if you remember back to year 8 geometry, you might recognize that these two lines are parallel and those two angles are in fact alternate. and alternate angles in parallel lines are equal. So what we can come up with this statement is the angle of elevation is equal to the angle of depression. They're always the same value, which means regardless of what they give us in the question, whether it be elevation or depression, we can generally always write it in that bottom part of the triangle. Now, technically speaking, I like to see the angle of depression drawn in if they tell us about angle of depression. However, you won't be marked wrong. Just put it down the bottom. Don't ever put that angle there. Okay, yes, I can find that angle depending if I know what the angle of depression is. It's going to be what we call it, a complementary angle, it adds 90 degrees, but certainly I wouldn't bother. Now, I'm just going to show you, before we look at some actual examples, two kind of ways they can present that information. They like doing trees and they like doing boats and cliffs. Okay, lots of different ones, of course, but they're two really common ones. So this one talks about the angle of elevation from a boat to the top of a cliff. So any of these questions, all I'm interested in at the moment is a right angle triangle. Now, of course, you could draw a little boat here if you wanted to. You could show that's my little cliff up the top there. And what we're looking for is angle of elevation from the boat up to the top of the cliff. And so you can see the angle of elevation is sitting inside that area there. Okay, now often when I'm doing these diagrams, I don't bother putting little pictures there because they detract me from what's actually happening for my right angle triangle. For the second example there, the angle of depression from the top of a cliff to the boat. Well, if I'm sitting at the top of the cliff and I'm looking down to the boat, well, I look across first and I look down to where that boat was. And that's my angle there. And you can see again, they are alternate angles. And that's good because if we know, for example, we're told that the angle of elevation is 20 degrees, well, then we also know the angle of depression is 20 degrees. Okay, which is nice and easy. If you really want, you could then say that the angle in the top of that triangle would be 70 degrees because it has to add up to 90. But to be honest, there's no real need to do that. So that's the kind of idea what we're doing with in terms of coming up with our diagrams. For 5.3, you'll start doing some bearings after today. It'll get a bit more challenging. But certainly for 5.2 and 5.3, angles of elevation and depression are really significant to get those diagrams. Now we're going to look at a couple of questions. The first one, of course, I've given you a diagram here. And to be honest with you, as long as you know what length you're finding, you don't really need to look at those words. But we're going to imagine that that diagram is not there, and we're going to construct the diagram regardless. So it says in this question, the angle of elevation. Okay, that's really important. So across and up. Okay, of the top of a tower from a point on the ground, 30 meters away from the base of the tower is 28 degrees. Find the height of the tower. So let's start with a nice right angle triangle. Yes, I know the diagram is there, but just try and ignore it for the moment. Now, it says the angle of elevation is 28 degrees. So elevation is across and up, which means the angle there is my 28 degrees. We are told from the point on the ground away from the base of the tower is 30 meters, and it's asking me to find the height of my tower. So quite quickly, even with that diagram there, it's pretty easy to come up with my diagram, right? And now all I want to do is find the value of h. So once I've done that kind of initial step of creating a diagram, let's now follow our 4-step process. So step 1, we label. Okay, so we've got, in regards to 28 degrees, we have our opposite side and we have our adjacent side. Step 2, I said before, to identify or choose your rule. So SOHCAHTOA. So looking at this, we have opposite and adjacent, which means we're using tan, TOA, right? I will say as well at this point, a lot of your application questions are tan, but not all of them. So don't just assume it's always tan, because it can be the other ones as well. But don't be surprised if you see tan come up quite a bit. Number 3, of course, we now want to apply the rule. So of course we know the rule is tan theta. So tan 28 is equal to my opposite over my adjacent. Okay, perfect. And step number 4, of course, was to now solve that rule. So now what I'm looking at is doing something like 30 Actually, we'll say h equals 30 times 1028. Okay. Now, in terms of this, I don't have my calculator with me today, unfortunately. So you can do that calculation, all right, and double check it with the people around you. But certainly, all I'm going to do now is just double check. It says the height of the tower to the nearest meter. So whatever that calculation is, I think it was about 15, if I remember correctly. Whatever it's going to be, round it to the nearest meter. So again, you can see that my 4 steps from the last 3 lessons are exactly the same. There's no difference there, except I need to establish or create a diagram, and then once I've answered the question or solved my equation, we answer that question. We go back and see what was the rounding, what have they actually asked me to find. Okay, let's look at example 23. Now, in terms of this one, feel free to pause this and have a crack at it. As I said, we'll create the diagram, we'll then go through those steps, and then hopefully you can compare your answers to make sure you got the right answer. Okay, how'd you go? So from the top of a vertical cliff, so we've got a vertical cliff. Let's even just start with a nice diagram, because then what we can do is we go through, we can add information to it. So I'm at the top of this cliff, so top of the triangle. Andrea spots a boat, there we go, a boat out to sea. If the top of the cliff is 42 meters above sea level, well, of course your boat's down here, right? Okay, so we're going 42 meters for the vertical, and then boat is 90 meters away from the base of the cliff, so we've got 90 meters there. Find Andrea's angle of depression to the boat to the nearest degree. Now, personally, what I like to see, because it's mentioned that angle of depression, I like to draw the angle of depression in. Now, as I said, realistically, you don't have to do that and you won't be marked down if you don't. As long as you find the right angle, of course, but I would always prefer you to do this. So where would the angle of depression be? Well, if I'm at the top of the cliff up here, I'm looking out first of all, and I'm looking down to where that boat is. So my angle of depression sits right in there. Now, that's what I would like to see from you. However, if you simply know that the angle of depression is always the same as the angle of elevation, then that's fine as well. Okay, just be really cautious. Do not put your angle inside of there. Now, you could, of course, if you knew that you're going to take it away from 90 degrees, but a lot of people don't. They just put the angle inside there, and that's incorrect. So please be sort of refrain from doing that. So now look at this. I've got a really nice diagram. Okay, if you want to get rid of the, this stuff here and just have your triangle, by all means, go for it. Now, first step, of course, we're going to label my sides. We have my opposite side. Remember, it's opposite the theta. That's inside the triangle. We have my adjacent. Look at that again. It's going to be very similar to that last question. So we label the sides. We've done that. Step 2, we're going to look at our SOHCAHTOA. And of course, we can see, again, this is going to be TOA, tan. 3, we're going to now apply this to our question. So tan, now this time it is tan theta because I'm looking for my angle, equals my opposite of 42 over my adjacent, which is 90. Perfect. Now, once I've done that, of course, we're now going to solve my equation. Now, again, sorry I don't have my calculator with me today, okay? But what we're looking for is we're finding an angle. Now, remember back to that lesson where we're looking at angles. We can't divide by tan to get theta on its own. So we use that tan -1 of 42 over 90, okay? Or otherwise known as shift tan. So remember, whenever you're finding an angle, you always got to press shift first of all. Now, once I've done that, of course, you're going to get an answer, and it's going to be most likely a decimal rounding. Whatever that answer might be, my last step is going back to the question and answer the question. What is the angle of depression to the nearest degree? So we round it to the nearest whole number, and that's your answer. Again, have a chat to the people around you. Just make sure that you compare your answer to ensure you got the correct one, because I don't have my calculator to calculate it, so I apologize again. Okay, now, the last question I want to look at, again, you can pause this. This is a slightly harder question, of course. This is from the 5.3 questions, but certainly I'm happy for all 5.2 boys to have a crack at this question. This will still be a part B question. I know they've given a bit of a diagram, but they haven't actually drawn the triangle in. So although there is a diagram there, the kind of nitty-gritty of that triangle is not. So it's still going to be a part B question. So we have a plane that's flying 1,850 meters. So that plane, I guess, is already, so we'll put it at this point, he's already flying. Let's actually do that different color. Let's get that in a blue color. So he's flying at that height already, right? So he's going in a straight line, 1,850 to start off with. It then says the plane starts to climb at an angle of 18 degrees. So I'm assuming that he's kind of looking to do this, okay? Because he's going to try and get over the top of that mountain. And that's going to be sort of 18 degrees sitting inside here. It then says, the pilot says the mountain peak is 2,450 meters high, 2,600 meters away from him. Okay, we can say that's the 2,600 meters, which is already on the diagram. And we know that the whole mountain is 2,450, and it says, does he clear it? So basically, this is what I've got. I'm going to redraw this out so it's a bit clearer. Okay, I've got my 18 degrees here. I've got my 2,600 meters here. And what we're essentially looking for, we're looking for our height here. Now, we can work out what the actual height is in terms of the mountaintop, but we want to make sure whatever this H is here, it's going to be bigger, because the mountaintop, of course, if it's 2,450 high and we're already 1,850 in the air, well, let's do it quickly without the use of a calculator. 0 minus 0 is 0, 5 minus 5 is 0. Can't do that. 14 minus 8, that's going to be 6. So we're 600 meters, right? Okay, so we're trying to show that H is going to be bigger than 600 meters, whatever way you might look at that. But see, I've got my diagram, I've just got my triangle, and all I'm doing here is saying, okay, number one, we are going to label, because we've got the diagram now. We've got my opposite, you might see why I'm laughing, opposite and adjacent. So number two, we're going to identify the rule, and of course, if I look at soccer Todd, that's why I'm laughing, because yet again, I see what I said, most of these questions end up being 10, but not all of them, so be very cautious, don't assume. Third, we're going to apply that rule, tan 18 equals my opposite over my adjacent, okay? And then fourth of all, we're going to solve the equation, so H equals 2,600 times tan 18. Okay, now of course what we're going to do is we're going to solve that equation and we're going to compare that answer with the 600 meters. Of course, if your height is bigger than 600 meters, that means the plane clears it, okay? Because I know this part here is 600, we need that kind of plane to go like that, for example. So I then answer my question. Okay, that last step I spoke about. You get your H value, is it bigger than 600 meters? Hopefully it is, so the plane is safe. But if it's 600 or less, it's probably going to clip the top of that mountain, and that's going to be an issue. Now, of course, I don't have my calculator, so I can't calculate that, so maybe have a chat amongst you and see what answer you got and see whether or not your plane managed to go over the top of the mountain, or unfortunate, whether we're now picking up some parts of the plane because it hit the mountain. Gents, look, again, I apologize for not having my calculator with me today, but I just want you to understand when you're doing 2D problems, some of those nicer questions you'll be given a diagram for, particularly in 5.2, but certainly those harder questions in 5.2 and most of 5.3, you have to establish that diagram yourself. Then the 4 steps will come into play: label, then identify or choose your rule, apply your rule, and then solve your equation. And then finally, interpret your answer in regards to your question. For example, that last one that we saw, we got an answer, but now how do we use that to actually establish it? So just be careful, make your diagrams. We often say like 1/3 of your page because it's nice and big and clear. Particularly with 5.3, we get those bearing questions for next lesson. Big diagrams are really easy to use. So try and get in the habit of drawing nice big triangles. Remember, angles of elevation are across and up. that little angle inside there is created. Angles of depression are across and down, which generally sit outside of our triangle, okay? But angles of depression and elevation are absolutely equal. So for example, that last question, so the second last question up here, okay, if you had just to put your angle like that, and so that's my angle of depression, although it's not the angle of depression, it is still correct because it's the same as the angle of elevation. But I would love you to try and actually draw that angle of depression in because it makes me happier as a teacher. Have a wonderful day, gents. Any problems, please let me know. Otherwise, work through these questions that are set for you today, and I'll see you next time.